All right, today we're going to start the first unit or the first lesson of our new unit on triangles. So our last unit had to deal with just angles. And if we think about the word triangles, this word tri means three. So if we put three angles together and extend their sides, we're going to end up with a triangle. And if we look at any of these pictures here, we have angle 1, angle 2, and angle 3. And again, if we extend those lines and make them touch, we end up with a triangle. All right, so looking at these triangles, they have different parts. So it's helpful just to kind of refresh our memories of what the different parts are. So in your note packet, the very first page there, I think it's on page 3 actually, you'll see this exact note sheet if you'd like to follow along. All right, so labeling the parts of a triangle. The corners of your triangle, those are still called vertex. So again, we learned that word in our angles unit, but the corners of each angle in our triangle are called the vertex. If we look at the actual kind of V's, you mentioned this on the front side, right? Those are our three angles of our triangle. And if we extend our lines and make them connect, then we end up with the figure of a triangle. So those are still called angles. And then all the other space, if I just look at these sides, there's really no other word to say it, those would be the sides of our triangle. So again, if I'm talking about the vertex, I'm talking about just the corners there. If I'm talking about the angles, I'm talking the actual V shapes. And then if I'm looking at just the sides, I'm referring to just the sides, not the angles or vertex. All right, so to classify angles or triangles, we can do that by angles. We can also do it by sides. So first, let's take a look at classifying triangles by angles. So again, triangles are made up of three angles. At least two of them are going to be small. They're going to be acute. The third angle is what determines what type it is. So in an acute angle, all of our angles are going to measure less than 90 degrees. And again, an acute angle is less than 90 degrees. So an acute triangle is going to have all of its measurements less than 90. So this could be something like, let's say 60, 70, and 50. And angle measurements are found within the angle inside of the triangle traditionally. All right, so if we have an obtuse angle, again, two of our angles are still going to be acute. Okay, so we could have something like 20, 30. And then this third angle down here, right here, this is an obtuse angle. And we can tell that, again, visually it looks greater than 90, but let's say that it has measurements here. And this would be something like 130. So it would be, again, an obtuse triangle has two small angles, and one angle measures larger than 90 degrees. And in that case, that would be this guy down there, 130. In a right triangle, one angle is going to measure exactly 90 degrees. Oh. So again, if I have measurements there, it could be something like, 40, 50, and 90, if I'm using measurements. You could also most distinctly see the symbol, which is a square. So you may not see the number 90, but you would see this notation. That is a dead giveaway that it's a right triangle. All right, so let's take a look at some examples here. We're going to measure or classify this triangle by its angle measurements. Again, 45 or 44, 68, 68, all of those are smaller than 90, so that would be acute. Taking a look at this one, hopefully you see this right away. This is that 90-degree angle. So anytime we see that measurement, it is a right. Okay, taking a look at this next one, we have a 31, 31. Both are smaller than 90, so this third one is what's going to categorize us here. 118 is larger than 90, so that would be an obtuse angle, meaning it would be an obtuse triangle. Okay, looking at this one, take a look. 42, 104, 34. Hopefully set obtuse. This 104 here is greater than 90, so that is the angle measurement that's going to classify it. 60, 60, and 60. Hopefully you said acute. They are all smaller than 90. Hopefully this was a dead giveaway to you. You see this right angle, which makes it a right triangle. All right, so the second way we classify triangles are by sides. And again, those are those kind of connecting pieces between the vertex. So to classify by sides, we have three new terms: scalene, isosceles, and equilateral. So let's take a look at scalene first. Scalene have all sides are different in length, so none of them are the same. And how we usually see measurements for the side of a triangle is that we have numbers on the outside of a triangle, whether they've label or measurement labels or just numbers. So 6, 7, and 8 all different, so that would make it a scalene triangle. All right, an isosceles triangle. That would be a triangle that has two sides that are the same and one is different. So if I gave you measurements, it'd be something like 5, 5, and maybe 7. We see that two of them are the same. You might also notice these hash marks here. Those also indicates measurements are the same. So regardless if I actually had numbers or if I just had those symbols, those hash marks, we would know that with our two sides that are the same. This would be an isosceles triangle. I'm going to go ahead and throw those measurements back up there just so you can also see. But it doesn't have to have the measurements in order for you to see that this is an isosceles triangle. Last but not least, you see all three sides are actually equal in this one, and we can tell that by those measurements. I could also have values written outside indicating the side measurements, which would be 3, 3, and 3, but all be the same. So equilateral, all sides are the same in length, and I always think they're equal in length, and equilateral kind of does lean you towards thinking that way. So again, that symbol used to identify sides, those are those slashes, and you do common see those on triangles. All right, let's practice classifying by sides. Okay, so remember scalene, I always think of no fish's scales are the same, so they're all different. Equilateral means they're all equal. And isosceles, I always think of I saw two the same. So taking a look at this first example here, we have 3, 4, and 5. They're all different. Scalene. Taking a look at this one, 3, 4, and 4. So you should notice that you have two of them the same. That is the term isosceles. Okay, this next one doesn't have any numbers to it, but we do notice these hash marks, and this is saying that this side is equal to this side in that triangle. So we've got two the same, isosceles. 3, 3, and 3, so we've got all three sides the exact same measurement. They're all equal or equilateral. Okay, looking at this one, we have 4, 4.1, 4.2. They're all kind of close, but really all different, so those would be scalene. So scalene triangle. This one right here, we don't have any measurements, but we do see these slashes. So slashes mean that they are the same. All three sides are the same in this triangle, so that would be an equilateral triangle. All right, so you're going to be asked in your homework to do both classifications. So again, when you're looking to classify by angles, we are looking at those numbers inside the angle measurements themselves. So classifying this triangle by angles, we have 67, 23, and 90. 90 indicates a right angle. So it'd be a right triangle. If we're classifying by sides, we need to make sure that we're looking at the numbers on the outside of our triangle. So in this case, we have 3.5, 6.5, and 5.7. Those are all different. So if you remember our definition, scalene is the term there for when all of our measurements are different in a triangle. So this would be a right scalene triangle. All right, take a look at this one. So again, if you're classifying by angles, we're looking inside. Hopefully you can see all of those measurements are smaller than 90, which would be, oh, so cute. It's an acute triangle. If we're classifying by sides, Outside numbers, 2, 2, and 2, they're all equal, so equilateral. All right, one more here just to make sure that we are getting the hang of this. So again, if we're looking at by angles, there are angle measurements there, 30, 120, and 30. That would make an obtuse because of the 120. If I'm classifying by sides, I'm looking on the outside of the triangle here, 4, 4, and 6.2. So you see two of them the same. Hopefully you remember that is isosceles. All right, so as I mentioned, your homework is going to consist of problems that require you to look at your picture, classify by angles, and classify by sides. So good luck. Let me know if you need any help or more assistance.